Hello and welcome to PyData Manchester. Thank you all for joining us for our very first remote meetup. Obviously, it's a bit different for all of us here, but we were excited to get to go ahead with it. So, as you know, it's going to be a geospatial episode this evening, and we've got three great guests, and we'll introduce them very soon. But if you want to get in contact with us, we're available on Twitter at PyDataMCR, at Slack at the link, and of course we've got our podcast as well. So in terms of who organises this, hopefully you all recognise us from our Manchester-based events. But if you haven't been lucky enough to join us in person so far, here are our smiling faces. We've got Joseph, John, myself, Jennifer, and Sean, all of whom will be available via different communications on Twitter, on the YouTube stream, or in Slack. So, as with any of our meetups, this remote event is governed by the PyData Code of Conduct. It's really important that PyData is a dedicated, harassment-free experience. It's a professional environment, and everyone behaves as such. We try and have fun, but make sure that it's a professional environment in which we're kind to others. So just in terms of some events we got coming up soon, or our friends have in the Manchester data area, although certainly it's going to be much more remote than usual. Open Data Manchester have got their Open Data Surgery coming up tomorrow. Again, this is going to be remote. On April the 7th, Our Ladies Manchester are hosting their event. And on April the 9th, Her Plus Data are hosting their event, transitioning from academia to tech/industry. You'll be able to find links to all of those events on the PyData Manchester Twitter feed, as we'll be retweeting them vociferously. We've just released the our most recent podcast today as well. The Open Data Manchester podcast, in which we spoke to Julian and Sam from Open Data Manchester. Fantastic conversation. Hopefully it's a fantastic listen as well. And soon we'll be recording our recommendation systems focused podcast as well, which will be out in the end of April. So if anybody is looking for a job or is looking for people to take jobs, in the Slack, in the #jobs channel, please pop in there. I know there's a lot of people looking at the moment, and luckily a lot of people are hiring for remote roles as well. So hopefully can make those available for everyone. And again, if there's any meetups, then please we'll be happy to share in a Slack. So if you want to get involved, get in contact with us again. We're always looking for speakers, guests, sponsors, and people to get involved with organizational help. So in terms of tonight's events, we've got Dani Arribas-Bel from the University of Liverpool. We've got Dr. Rachael Reynolds, who works for Jacobs at the moment, and Dr. Jack Snape from Transport for the North. And much as we've already got some prepared questions, and we're really looking forward to, we're really hoping to get some questions from you, the audience. So if you go to this this link at slide.do, PyData-geo-panel, you'll be able to put your questions in there, vote on other people's questions, and then I'll be able to ask our panelists those questions themselves. So first, again, we want to thank our sponsors, without whom this wouldn't be possible: Cathcart Associates, Horsefly Analytics, Google developers who help us with this, and of course, most of all, NumFocus, without whom a lot of the code that we use and rely on wouldn't be available at all. Normally, we'd like to go down to the to a local pub or something to share some drinks, but unfortunately we can't. So we'd like to have a networking kind of situation. So this is all definitely going to be available in Slack. Hopefully we can all have a chat in there in the meetup channel. So without any further ado, going to move into, we're going to introduce the guests. One moment while we sort it out technically. Okay, so welcome our guests, Dani, Jack, and Rachel.
Hello, thanks for having me.
Thank you for joining us. So I guess let's start off with Dani. Can you kind of introduce yourself to the audience?
Yes, so I'm Dani Arribas-Bel. I'm a senior lecturer in geographic data science at the University of Liverpool, and I'm also part of something called the Geographic Data Science Lab, which is a research unit within the university that focuses on, well, bridging geography and data science in various ways. So we're all different versions of social scientists who are really interested in data and the algorithms that help us do stuff with data. And I'm particularly interested, my background is in economics, actually. My PhD is in urban economics. I started originally interested in how cities, why we have cities, how we can characterize, measure cities, and how different activities that take place within cities can be measured, modeled, and analyzed, hopefully to make better decisions.
Fantastic, thank you. Jack?
Hi, so I work at Transport for the North, which is it's the UK's first subnational transport body. It's a statutory body that is sort of based out of all of the local authorities in the north of England and is sponsored by the Department for Transport. And our role is to really find ways that transport connectivity can help to rebalance the UK economy and get economic growth into the north of England by connecting up all the towns and cities. And we have to use a lot of future scenario modelling to understand how new rail connectivity and road connectivity will help to achieve that over the coming decades. And my role is really looking after a lot of the wider economic modelling, looking at the way the economy, households and businesses might respond to this big change in transport connectivity.
Sure, no, fantastic, thank you. Rachel?
Hi, so I currently work for Jacobs Engineering. But before that, I worked as a regular lecturer at the University of Chester, and my background is in spatial epidemiology. I did my PhD on predictive modelling of disease. So I predicted the changing spatial limits of malaria in Tanzania. And a lot of this was brought on by different data. So specifically climate and climate change. I built predictive models to see how malaria would change with changing climates going forward. And further looking into the impacts that would have on Tanzania as a society. So what policy implications might have on how that tied into the data as well.
Cool, thank you very much. So I guess, first of all, it seems quite pertinent, given that your background's kind of in epidemiology. The current situation with all this. How do the two link up? How is epidemiology, which seems very much associated with people and viruses living in people, how does that play out in a data science and a spatial situation?
Yeah, it's like I say, it's very prevalent at the moment. People provide data, so people are sources of data themselves, and their movements very much assist with the spread of disease. So linking back to where they move geographically, we can start to say, well, this disease originated here, this group of people have moved over here, it is now spread. This climate has stopped that, say, for example, from existing. So we're bringing in another data set there. Again, it comes back to looking at transport routes, how people are getting around, and again, social behaviour, if they're a very connected society or perhaps a bit more disconnected. There's all sorts of information we can draw on to say how this moves and why it's there.
Cool. So, I mean, what kind of, from a data science perspective, what kind of approaches would you use to model that? Is it anything we might recognize?
Yeah, so the most basic disease models start as things like as simple as weighted sum. So you're just looking at, taking a quantitative value. It's very hard to bring in qualitative data just because of the unpredictability of it. But we'd start off with things that we know are hard facts. So that the disease takes this amount of time to incubate in a person, and it can only survive between these temperatures. And then we'd rank them by importance and how this affects the disease. So with malaria, temperature and rainfall are very important, so they are weighted more highly than, say, humidity or other environmental variables like that. So from a data perspective, we would want to then just get as much information as we could, but then balance it out as reasonably as possible to reflect the true nature of the disease, which is very difficult to do because people are involved.
Yeah, that always seems to be the confounding factor, people being different. So it does sound an awful lot like kind of both with transport and in epidemiology, the movement of people is key. So how can you, it sounds very difficult from my perspective to even approach tackling a problem where a range of people could take a range of decisions.
Yeah, I guess there are a lot of like network analysis comes in. You have to, look at most used routes. I'm sure that somebody else feel free to jump in here, but yeah, like well-traveled routes, perhaps less so traveled routes might get less risk from catching a disease through that method. Or if it's a city that drives more than it catches buses, you then have to start to look at, well, there's use of taxis and things like that. And yeah, I think the networks are a big part of that.
Yeah, so
What's happening with the sound there? Would you mind muting for a moment, Rachel?
Sorry.
transport modeling, we tend to think about the way people make choices in terms of what's called a 4-stage model. So it's kind of like a hierarchical choice model. So a person will first maybe decide how many trips of different sorts they might want to make in a day, and then you'll think about trip reductions as in where people live, and then attractions, so workplaces, leisure destinations, that kind of thing. And you'll work out how many attractions there are within different distances of the home base, and then you'll sort of distribute those according to like a trip length distribution. And then from that you might look at mode choice. So does the person have like better rail access than they do car access, and will that sort of influence the mode split for that particular location? And then once you've decided what mode, you look at route assignment. So there might be a number of different routes available. So from those like 4 stages, you get like a range of different, like a spread of different travel choices for every origin zone. And within each origin zone, you might segment the population. So you might look at traveler types. So looking at kind of whether people are employed, full-time, part-time, what occupation type they have, whether they have a car or not. So you end up with all these like sub-segments within each zone that might have different kind of travel behaviors, and that's all based on like survey data that you can build that information. And then different trip purposes and different times of day can also be kind of layered on top of that. And you can get from that sort of like quite detailed segmentation, you can get a really interesting range of travel patterns that can vary by spatial location, depending on what type of people are there and what type of choices are available to those people.
It sounds like there's an awful lot of distributions involved there. I mean, is that kind of something you might take a Bayesian approach with?
We've certainly looked at Bayesian stuff when we've been trying to merge different data sets together. So there's no one perfect data set. You've got things like the National Travel Survey, but that has quite small sample sizes of like a few thousand people every year. So you can start to build up like prototypical kind of travelers from that. But then you have to sort of synthesize that together with other data that's available at a more kind of comprehensive distribution. So looking at ONS data sets, looking at the census, even though it's really old. And when you start to merge those data sets together, we also use sort of mobile phone data as well, looking at trip patterns. but you have to kind of take the good bits from each data set and maybe use Bayesian approaches to kind of merge them together.
Okay, that makes sense.
Yeah.
I mean, Dani, do you have any thoughts on this?
Not, I haven't done a whole lot in terms of tracing individuals. The only thought that I actually had when you were asking this question of whether it sounds very hard to predict individual behavior, I think that the short question, like Rachel said, is true. It is very hard, but that's also why we have a job. Otherwise, we probably wouldn't get paid for doing these. The other thing that I would add is that, and this is the social scientist getting in me, is that individuals are terribly hard to predict, but in most cases, you don't necessarily need individual behavior or individual predictions to make good decisions, and group-based behavior is okay. So a lot of the topics that I usually work with involve areas or places like neighborhoods or cities or parts of a city. And at that point, aggregated behavior is surprisingly much more regular than individual. There's a lot less randomness and a lot less tricky bits that make it hard to predict what one given person is going to do at one given point in time. And that's why I think we can do some of the seemingly magic predictions that we actually make and be not terribly wrong all the time.
Okay, no, that's a really useful perspective on that.
Yeah, I think that's a really good point. Another tricky area is when you start to think about a little bit further into the future. So we use a lot of data on, current travel patterns, but you can already see travel patterns really starting to change with kind of mobility as a service, with kind of app-based travel, people doing trip chaining, and the way as that gets more and more widespread, it gets quite hard to start using current trip making patterns for those completely new services that are available, and the way people might kind of link together trips with those sorts of services and mix their modes across a trip will just sort of emerge in ways that will be quite difficult to predict, I think.
Sure. So I mean, I'm sure there's I'm sure one of the main things you'd be looking at would be, say, when you're introducing a new mode of transport through to the north, HS2 or something after that, that would involve trying to predict new travel patterns with new infrastructure.
Yeah, the way we try and do it is we sort of try and think about everything in terms of costs. People like, even the time people spend traveling can sort of be converted into a cost because people have kind of a value of time. So if you try and kind of convert those new modes into like, what are the kind of perceived costs, the barriers that people might have to using it, or the advantages compared to those other modes, then you can start to try and predict what kind of mode share they might steal from the current modes potentially. It's tricky though. It's certainly not predictable.
Yeah, for sure. Rachel, should we try and see if we can hear you again?
Hello?
Hey, okay, that's excellent. What a relief.
Cool.
I'm not sure what happened with that. Okay, so each of you, although you're from different areas of geospatial data, you try to understand how individual and social behaviors manifest themselves. How do you go? We've touched on this a little bit already, but how do you have to go from modeling individual actions and movements to groups and social, to go from individual actions to groups and social behaviors? We've spoken a bit about Bayesian and probabilistic methods. Are agent-based models the kind of things that you'd use? And I mean, if not, then I mean, if you don't actually have to look at individual movements, yeah, how come? Because just from a perspective of someone who knows very little about geospatial and geospatial data and what each of your roles entails, it'd be interesting to get a perspective on that.
I'm happy to jump in. Can you hear me now? Is it all good?
Yeah, just fine.
Great. I think it kind of goes the other way around. So yeah, I think like Dani was saying before, Daniel was, we start, well, at least I do in terms of health, start quite broad because the data resolution just isn't good enough. It's very challenging to get the resolution of data on an individual level, especially for health and especially in remote areas in sub-Saharan Africa. So the European countries are quite good at data collection of health, but then you have a privacy issue as well. So at least in my experience, it's always been more grouping of behavior and trying to model it that way. But I am quite interested in applying agent-based modeling on sort of like what the impacts of an individual behavior could be. So I think in that respect, it's interesting, but at least in my area, the data just isn't there. So it's trying to balance out the resolution of the data with what you actually want to achieve and what you're trying to look at.
Sure, that makes sense.
I'll jump in on this on the question on how do you go about picking methods, or what methods do you go? I guess it'll show again that I'm a social scientist at the end of the day, and I can't escape that. But usually, all of my
There's nothing wrong with that at all.
Oh, okay. Sorry, I thought you meant I was muted, and I was like, "Is nobody hearing me?" Yeah, and no. So what I was going to say is that ultimately, I'll have a question that I want to ask. To answer. Is what it could be: why is employment concentrated in cities? Where are green spaces in the city? How are they distributed? Do they follow a pattern? Sometimes, usually, there'll be a theory or several of them behind that that try to shed some light on the answers. But and a lot of my job is usually trying to merge these more theoretical questions with empirical answers to see if the theories actually are any good or not. In other cases, we know that there's a lot of theories that require certain measurements that are just not a trivial thing to do. So, for example, if you're looking at, as I was the example before, as green spaces or exposure to green spaces, a lot of theories that suggest that green spaces are good for physical health, mental health, etc. Turns out actually measuring green space in theory is very easy. Doing it well and at scale is nothing trivial. So it's then when I start thinking about what methods might be what might be the best tool for the answer. And usually, or at least more recently, the choice of methods is also informed by the type of data that I am either thinking of using or that I can use, or that it's going to be the contribution. So in some cases, there's been a lot of very clever people over the last few decades trying to figure out these questions, and the key differential that we have today versus what could have been done, say, 10, 20 years ago, is that we now have data sets that allow us to look into these problems in different ways. And in that case, actually looking at new data sets usually leads to trying to at least play around with different data set, different methods. So, for example, I'll give you an example because I might be being very general and conceptual, but an area that I've been looking at recently quite a bit is, I've always been interested in characterizing cities and their built environment. There's a lot of information about that. The census provides a lot of information. The Ordnance Survey has a lot of data that they've collected very painstakingly over time. That is very expensive to create. It doesn't change very rapidly. So something that is becoming more of an option lately is using satellite imagery, which we have, and I'm sure Rachel probably is familiar with this as well, because this is true in the developed world, but in areas where there's not a lot of good traditional data is even more present. So satellite images, we have a lot more of them. They're coming a lot more regularly, and they are getting better and better by the day almost. It's hard to argue against the fact that if you look at a satellite imagery, there's a lot of information about the places that are being captured in that image. The problem is that that's not what we would call structured data, right? It's not a table that tells us these are all buildings, these are the buildings, these are their shapes, this is their area, etc. It's just encoded in colors, right, in pixels. So to translate that into a more structured and traditional form of data that we can then process and use to answer the questions we're interested in, we usually have to resort to methods that traditionally, at least myself, I hadn't been very much exposed. So things like computer vision, machine learning, etc. So then that's usually what drives me approaching particular methods. And then the final bit that I was going to just throw in there that maybe other people in the panel might pick up on is that I'm not necessarily always going for Bayesian or probabilistic methods, but probability is something that's always very, very important to me, because usually a lot of the things that I a lot of the questions I try to answer, a lot of the people I try to inform, at the end of the day, they don't want a single prediction. They also want to know how much they can trust it, right? So it's not good enough to say this is the best I can do. I also have to say to some extent, and this is how much you can, this is some bounds to give you, so you know whether this is good enough for you. Because being the best that you can do doesn't mean that it's good. And that might come from Bayesian or frequentist methods.
Yeah, no, that's a really good point. And it does kind of bring up the question of kind of what's the outcome of your work. Right, and in case there's always lots of really informative analysis that can be useful, but how you go about taking an action with that in everyone's line of work. So yeah, Jack, feel free to go ahead.
I really agree on some of the points made there by Rachel and Dani. So I think what the level of data you have available is key to informing what methods you're going to choose, and also what's the question that you're asking, because I think a key thing is there's no point adding more detail and trying to get down to that individual level and thinking about agent-based modeling if it doesn't make a difference to the question that you're trying to answer. So don't kind of go down to smaller and smaller subgroups in the population if actually that's not going to make a difference to your final prediction. So it's that, does it make a statistically significant difference if you start to go beyond that kind of broad average. One thing that we do in my line of work is in some cases individual behavior is quite important. So for example, like thinking about the way people move through junctions in the car, you get quite a different answer if you look at the way individual cars kind of interact with each other and the kind of human responses with braking and things like that, to if you just assume kind of like these fluid-like traffic flows through a junction. So what people do is do like kind of micro simulation of an individual junction that's calibrated to these small individual behaviors, but then kind of take from that some broad macro more broad macro kind of curves that you can then use in a less detailed model. So if you want to build like a big regional model like we do of the whole North, you're not going to be wanting to be simulating individual junctions, because that's just never going to run. But you can understand individual behavior in a micro level for a small scale, and then kind of expand it out to a broader region. And it's really important for us as a regional transport body that's trying to support local authorities in doing analytics as well, that we also go down to that fine spatial scale. One of the things we're trying to do is build models that are kind of tiered. So you have like a big aggregate regional level model, but it's built up of lots of smaller models, and we're developing these data sets and spatial data sets and tools that we can give to our local authority partners and save them a load of money. And also they'll be consistent with the regional level models. Yeah.
Thanks. Rachel, Dani?
Yeah, I'm happy to jump in just to follow on. It's almost like the reverse of and kind of similar to what Jack just said. Where I said before, obviously, about when you start off looking at a disease, you might, if it's like malaria, it's been going on for years, you might want to start broad and trying to narrow it down. With the case of coronavirus, what you would want to do is the reverse. So again, you'd be interested in individual behavior, who first started to show these symptoms, who did they contact, who did they talk to, what was their network, and you would have to try and work outwards from there. So you start with sort of a couple of points on a map and where these cases arose from, and then who did they talk to, where did they move, who did they speak to, who are they in connection with, are they a diplomat, do they travel, and then you start to build out the network from there, and that's when you can start to build your model, because it's everything about this was previously unknown, and how it was spread, it's novel and it's new. So we have no existing data, and that's where you'd want to be interested in the individual to start with, because that's all that there is. And we start to build it out from there. Again, it comes back to the method that you choose is purely available. You base it on the data available. So that's just an example of how decision making then would come into that. Is you'd have to make your best guess on the data that's available, which obviously for this case has not been a lot of information up until it escalated.
It's always the way of making the most of the data available. Dani, have you got anything to add?
Yeah, I was just gonna chip in a thought or two about this idea of thinking about your audience. That almost every work, definitely almost every data work that I've been involved in, most of my research anyway, when even from the point where it starts and when it's conceived, it's going to end up being in very different places. So in some cases, it might be a purely research-oriented project in which you're trying to figure out some more fundamental models about, or not models, but fundamental patterns about behaviors that are not necessarily directly applicable, but that tell us something and help us learn something about how individuals move around cities, or how cities behave under certain circumstances, etc. And that would be more of, what you would traditionally call basic science or fundamental knowledge. That will probably end up in an academic article that about 20 people in the world, if you're lucky, will read, and that's useful. I mean, that's a good chunk of my work and my job, but that's not always the case. And I think there's other cases where the work I'm doing is going to be used either by policymakers or by non-technical audiences. And in those cases, it's really important. It's almost like a design problem. You have to figure out what is exactly what whoever is going to end up consuming the output of your work is going to need, and what's going to be is the same as teaching. You have to figure out what is the audience like and what you can pass through. And just because you give them more information and more detail doesn't mean that they're going to absorb more. So when it comes to using data, for example, you might be able to figure out very sophisticated results of a advanced predictive model, but if the audience is not going to be able to engage, it's probably not going to be super useful. So something that would fit really well into an academic article doesn't necessarily fit well into a more general audience type of output. And in that case, actually, I think a lot of academics like me start by thinking that that's a trivial transition. And something I've learned in the last few years is that it takes real effort to figure out how to please, in a good sense, your audiences, how to understand them and communicate what you find in ways that is going to be useful for them.
Yeah, that's some really good points. And I think useful to anyone doing any analysis is thinking out how best to communicate your ideas.
I have just thought of one example which really kind of highlights this intersection of data quality and human behavior, and really thinking through what your data is actually telling you. One of the problems we've had recently is we always used to use ticket sales data. We still do use ticket sales data to try and work out where people are going by train, what kind of trip purpose perhaps it is, because the ticket type might tell you something about whether it's a business trip or a commute trip, for example. The thing that's really started to throw a spanner in the works is split ticketing. So people using these websites to save money going from London to Glasgow. It looks like we've got two people, one person going from London to Wigan and another person going from Wigan to Glasgow, and suddenly our trip distribution's messed up. So we've got to kind of look at that data and try and work out, what's the scale of this? Are there particular types of people who are doing it more than others? We don't really have good data on that. So human behavior and the internet kind of messing things up for us, but interesting. It might tell us something interesting about what types of people are making those choices, and are they more savvy about the technology that's available, and can we build models that start to predict that in future potentially.
Yeah, like you said, limitations of the data available.
Yeah.
Okay, so we've spoken quite a bit about data sources, which are obviously key. So we've mentioned the census a bit. We've mentioned satellite images. Are there any other kinds of data sources that you use or that you think could be interesting to use? Rachel, do you want to go ahead? Dani, go ahead.
I'll let Rachel jump in.
Okay, great.
Yeah, so a lot of my predictive modeling kind of stuff, especially in terms of using climate models, obviously came from a model, and that itself throws up another challenge. It's great because you get a gridded output and you get all this, predicting where peak rainfall is going to be in May in 2070, and that's fantastic. But the important thing to remember is that actually it's a source of data, and it is a very valuable one, but that still comes from a model. So putting model data into a model is you've got to try and account for that. But sometimes you're left with no choice. So especially because this information was driving the change in this disease presence, there was no other data. So, we don't have data from the future. You can't do anything about that. So in some cases, if you want to predict the future, you're going to have to use a model output to drive another one. And that is, although good, it's all that we've got. It throws up its own problems, and you have to try and account for that and balance that, and that makes your modeling job harder because you have that data in there. So I'd say it's good, but use it wisely.
Well, that makes sense. Dani, you almost started before.
Yeah, no, I would say in terms of data sources that I'm most familiar, that I would be using most commonly, obviously what we would sort of despectively call traditional data sources, the census and official surveys and so on, they almost feel like boring, but I think I can never be grateful enough to those data sources, because almost everything else that comes on top of it, we know how good it is based on these traditional sources, and it's super, super important that we're clear about that a lot of what we now call new forms of data would be very, very useless at best and misleading at worst if we didn't have anchors to representativity, so to speak, like the census and so on. So I do a lot of work with official sources. I'm trying to do more with satellite data, and I've done quite a bit in cities. In a way, it's like a candy store for somebody who likes data, because it's like everything that happens in society happens more concentrated, right? That's the beauty of cities, that everything is closer. Well, the beauty and the not so beauty, as we're experimenting and learning these days. But there's a lot of different sources of data. So other examples I've used a little bit of the other panelist, Jack, was saying cell phone data, a little bit of social media, although there's so many, like Rachel was saying, that there's so many ifs and buts and maybes and who knows, that I'm not entirely sure there's a lot. Well, it's tricky. But I've used a little bit of that as well. And then more and more now we're seeing data feeds coming from sensors of different types, either beacons or so Wi-Fi or Bluetooth beacons, or cameras that automatically process on device pedestrian counts and that kind of thing. And there's some now. There's a lot more than there used to be 5 years ago. And I would say that if I had to make a prediction, that there will be a lot more coming in soon. And as soon as we can tap into some of the data collection that things like self-driving cars and so on will be doing, you can multiply that by 100 or 1,000 times.
Yeah, thanks for that. I mean, there's certainly, I know of some companies who do have access to card data already. I'm not sure if it's, I know it's not publicly available yet, but
yeah, there is, and it exists, but I think it hasn't scaled to the point where, it can tell us something about society rather than about the 10% or 5% that can afford those cars.
That makes a lot of sense. Jack?
Yeah, I'd like to echo what Dani was saying earlier about the Ordnance Survey data, because one of the really great things about that is it's so detailed and comprehensive. And the point that Dani made earlier, that buildings don't really move, they stay where they are for decades generally, and we can kind of roughly predict what their uses are going to be. So you can look at the census, and you can look at the Ordnance Survey map from 2011, and you can sort of look at what people were in what buildings, and then you can make some inference about how the buildings have changed between 2011 and 2018, and start to say, well, what are the people going to be? What kind of people are going to be in new buildings in a similar kind of area in 2018? And it goes down to such a fine spatial level that you can sort of synthesize kind of inferences down using that data on the buildings. One of the types of data that's really important to us that is perhaps a bit limited, and we'd really like to see the government doing more on, is business data. So understanding, where people work, what kind of economic sectors they work in, what the skills of the people in the businesses. How do businesses trade with each other? We have very little data on business interactions spatially. One of the really interesting things that was in the budget a few weeks ago, it kind of feels like a distant memory now, was there is a new fund looking at new economic data sets. I think that's going to be a really interesting area that hopefully when this is all over, we start to look at again. I think it was something like £25 million over 5 years for organisations, public sector, and I think academia, maybe to try and work with people like the ONS to develop some new economic data sets using things like tax records and other disparate data sets to really build out to the standard that it is in other countries. If you look at like the Netherlands, they have really good interregional trade data, and it allows them to really understand how their economy is working spatially, which we have a fairly limited ability to do in this country.
That's fascinating. I'd never even considered the aspects of business data in geospatial data, but of course, with all of the work around economies, around cities, it's key.
Yeah,
I think that's. So I was going to jump really quickly in there and just say, the government's recently announced the Digital Geospatial Consortium, and I think that is a real hope to start to bring a lot of this data together, because we are quite far behind countries like the Netherlands in terms of we have so much, but it's just not being brought together in the way that it could be and used in the way that it could. So that's a good space to watch for geospatial information going forward.
So just to reiterate, the two new data sources or funds, the Geospatial Consortium.
Yeah, Digital Geospatial Consortium. It's a government one. You should find it on the government website.
Cool. We'll try and put a link out to it as well. And Jack, what was the one you mentioned?
I don't know what the name is, but it's some sort of treasury fund for new economic data sources.
Cool. Well, we'll try and put a link to that later on so that people can find it. That's fascinating and way more optimistic than I was particularly expecting. So that's really cool. So thank you to Rika for that question as well. That wasn't me, that was Rika. So we've got a question now from Rachel. What technology does the panel like to use for their analysis? File formats, software, etc. Anyone want to go first with that?
Sure, I can jump in. In terms of technology, as in programming languages and platforms?
Let's keep it as broad a definition of technology as you want. So it's up to you.
Okay, this is one of my favorite hobbies to talk about. So I'm a big fan of Python. I've been doing Python for the best part of my career, first as a side hobby, and then as a more and more important part of my, well, not my job, but my role, I guess. So I'm a huge fan of Python. I like Jupyter a lot, and all of the possibilities that it allows us to sort of bring together both analysis and narratives and ways of communicating that analysis and so on. So that goes obviously on for Jupyter notebooks, but not only the notebooks, the whole ecosystem from the Jupyter project, I think is incredibly useful and very well thought out. So that includes the tools for Jupyter Lab, but also the platforms that are developed around that, like Binder and so on. And then I'm sort of running through the entire stack. So at the very top, I always think of it, the notebook, which is what sort of captures everything that you do that's unique about your own analysis. And then that's supported by open source packages like Jupyter Lab or like Pandas or like any other package that you're interested in. And then something that I've been really interested lately as well is how do we think about making not only analysis, expanding the definition of reproducible analysis and reproducible science, right? So if you stop at the notebook level, basically you're saying that, it works on my laptop, it's fine. What's the problem if it doesn't work on yours? And I think that, that's an ethos that a lot of people run by traditionally, and it makes you feel very good probably when you say that, or some people, I think obviously it sounds like it makes them feel very good, but it's actually not very helpful if you are interested in making your analysis actually reproducible. So in that context, I think it's useful to start thinking about reproducible platforms, or how can we think about making the entire stack all the way down to really the OS in a way that is easy to ship and run in different contexts. So in that is not ideal, but something that I'm really that I'm a big fan of is Docker or container technologies, and I've been using it quite a bit for personal use and for more work, like in the last few years. And in terms of geospatial formats, I don't know. I probably don't have too strong opinions. I'm in the last few months, I've become a really, really big fan of geo packages, but I don't know if that means much. I mean, I think the world is, the time is ready for something that's not a shapefile. I'll leave it at that.
That feels like it's almost controversial.
Yeah, well, that's what a panel's for, right?
Yeah, I love it. Go ahead, Jack.
So for transport modeling, we do use some kind of bespoke transport modeling software, but I won't kind of dwell on that too much. We try and use Python as much as possible for a lot of our kind of population demographic modeling and the sort of transport demand modeling. It's when you get into the kind of route assignment stuff that you tend to need this sort of bespoke software. For geospatial kind of visualization and analytics, we do use QGIS quite a bit, and we use quite a few of the Python libraries like GeoPandas and stuff for that as well. In the spirit of being controversial, one of the things that we struggle with is some of our models are absolutely massive and they take hours and hours to run. So Python is often not the best thing to use for things like that. They involve a lot of loops, a lot of convergence, and I've been rewriting things in Fortran recently because that was, as a physicist, that's what I cut my teeth doing. So I've managed to speed something up that took sort of 40 hours to run into a few minutes because it was a sort of nice compiled thing. We are going to start experimenting using Python, sort of that converts Python into a compiled C executable. But when your model takes tens of hours to run and you can make it run in minutes, then what's not to like about that, really?
Yeah, that seems like a very good reason to be using C in Fortran.
And that's all open source, of course, as well.
Yeah, of course, and we love open source. It's not about Python here today; it's about open source. I wasn't expecting a Fortran shout out. Go ahead, Rachel.
Yeah, I was really surprised by Fortran. I think it actually just stunned me into silence, but that's really cool. Yeah, I think I'm going to go the other way around. I'm going to jump on the controversial bandwagon and say geo packages for me is the way forward. I am sick of getting sent a shapefile that's not got a style layer with it or something that that is essential. A lot of the challenges that I face at the moment in my current job is getting .dwg, so CAD files through, getting that to talk to geospatial information systems like QGIS is very difficult. So that is the bane of my life. But in terms of software, I like the traditional QGIS sort of approach, I guess, partly for standardization. So with what Dani was saying before, if it's something that's been done in QGIS and it is a set, that's how it works. It works across everybody's computer. It's not a case of somebody can't go and replicate it because they haven't coded something quite right or their operating system doesn't support it, etc., etc. But I've been recently getting into R quite a lot, so I think that R is worth exploring. It's great. I think there's a lot of power coming there. It's obviously more of a statistical programming area at the moment, but they're building in a lot of functionality for geospatial, and I think that could be really interesting going forward.
Are there any R packages that you think are particularly useful?
So I've got a book at the moment on doing R and agent-based modeling. Sadly, I haven't read it. I was hoping to have got into it a bit more before this, so I could give you that. But I will pass on the name of this particular book. And yeah, a lot of the stuff that I've used has been more stats related at the moment. I haven't got down to the actual getting it to project some geospatial data. I thought I'd start easy with just some statistical work.
Nice and easy statistics. That brings us nicely into.
Can I? Can I just make a final point about the tools since we move? I realized actually that I missed a big thing. So, well, the first one is that actually I think both Python and R in the last 5-10 years have changed a lot for the better in terms of supporting geospatial analysis. And the fact that to this question, I didn't even answer QGIS when 99% of my work is GIS is in part because now you can do all of it. It doesn't mean that you always should necessarily, but doing stuff with geospatial data in both Python and R has radically changed in the last 5 or 10 years. And that's there's people behind that for the most part have been doing that unpaid. So a lot of the team that maintains GeoPandas, for example, and in R, the equivalent is SF, simple features. They do have support, but for the most part, a lot of these projects started as hobbies. And I think it's, there's part of these unsung heroes that we never think about, but actually if they weren't there, we would be screwed, to be honest. And then the final one is just a plug for a package, since you were asking specific packages. I think my colleagues will probably kill me if I don't mention it. So for the last 10 years, I've been working, or I've been part of this project called PySal, which is the Python Spatial Analysis Library. When we started, there wasn't this magic world of support for all these things. So we had to write a lot of the shapefile readers and more things than we wanted to do. But now actually we've got to a point where the ecosystem and the community is such that we can focus on the bits that we actually are interested, which is the spatial analytics layer, the more spatial statistics and the more analytical tools for dealing with spatial data. And then we can offload to projects like GeoPandas or Rasterio for the input, output, and others like Matplotlib for visualization, etc. So if you're interested in doing spatial statistics and more analytical stuff, or explicitly spatial geographic data science, some people would call it, in Python, I would encourage very much to check out PySal, which is not a federation of packages, it's not a package, but it's a common project.
Yeah. We've got a link to that in the stream. We'll have a link to that in the YouTube video afterwards. And it is worth, really doubling down on what you're saying, Dani. Just how important it is that we acknowledge the contributions of open source developers, because pretty much all the open source packaging with open source software we've got, GeoSpatial and otherwise, we wouldn't have without people giving up their free time. So thank you.
There is a package that I meant to plug actually that I haven't used, but from what I can see, it looks really good. It's the first transport modeling Python package that I found. Some colleagues who work for the consultancy Sistra pointed me to it. It's called Quetzal. I can provide the link for that. It looks quite comprehensive. It's got all the sort of different modules for different areas of transport modeling associated with it.
Sounds very interesting. Just making a note of it. So next we've got a question from Steve Miller. Have you got any go-to resources or textbooks or interesting reads on the kind of stuff you're talking about that you'd recommend? I know we've all mentioned a couple of things before, but has anyone got anything specific they'd like to mention while we're raising it?
I'll jump in since teaching is part of my job. Again, this is also something, at least in the Python world, where there's a lot of action right now. So the answer will probably look very different in 5 years, and it would have looked very, very different 5 years ago. So in terms of books, I'm not aware of any. Well, no, sorry. There is a geoprocessing in Python book that I can't remember the author now, and that relies on the traditional stack. So a lot of the traditional GIS libraries that have wrappers in Python, and for a long time that was the only thing that was available, and it's super useful. With the modern stack, so GeoPandas and PySal, Rasterio, etc. I'm aware of one book that is in the works for the more geoprocessing or GIS type of work, which was announced actually a couple of weeks ago. That should be coming out, I think, next year in CRC Press. And this is Henrikki Tekanen. I'm not going to even try to pronounce a Finnish name, but I can provide the link for that. And the book's built on the back of several courses and several course websites that they've built to teach GIS in Python. And then if you're interested in slightly more modeling or statistical based type of spatial analysis, I'm going to make another shameless plug for we're also working on a book that's actually currently being developed in the open, so you can check out what we have now, and it should be published later in the year. So I can also provide the book, but if you want to go to geographicdata.science, that's the website for our upcoming book. So I would say now there's about 70% there. It's probably an optimistic 70%, but it should be out next year.
Yeah, I've had a quick look at that, skim over it, and yeah, it's fun, really, really accessible, and obviously open source as well, and openly available. So we love that.
Thanks very much.
Have we got any comments from Rachael and Jack?
Yeah, so I was just having a quick look at the one that I was using. So it's an introduction to R for spatial analysis and mapping. That's by Chris Brunson and Lex Comer. I think that's how you say it. They recently brought out a second edition. I have the first one, which is what I was working through. It's not quite as academic. It's a bit more of an introduction. I directed my students to that when I was teaching, just to give them a bit of, not me teaching them stuff, to have them go and look through something. So I'd say that's possibly worth looking at if anybody was interested in going down the R route, just to broaden it up a little bit. I find typically that it's quite hard to find good GIS books, though. The technology changes so fast that it's out of date before you've even published it. So whilst it's one of my aspirations to maybe get a book eventually, I know that it'll be out of date less than a year later at the rate that technology is changing. So I would personally look at online resources, open online resources, because they will stay up to date more than a book would at this point.
Cool, that makes sense. Yeah, basically one of the exciting things about working in an area in which everything's progressing so quickly. Anything? Yeah.
It's very hard to actually find books in this kind of area, so I'd agree with what the other two panel members have said. We work a lot with the Institute for Transport Studies at Leeds University, so there's quite a lot of academics there whose work is worth looking at. Like most of the academics there do some sort of spatial analysis. So kind of if you go on their website and look at the academics who are working there, search some of their papers, that's a good starting point. I think there is a guy there whose name I've forgotten who has published a kind of a book for transport analysis using R. Sorry?
Robin Lovelace.
Yeah, I think that's right, yeah.
I think, yeah. It's a good friend.
Great, good stuff. But yeah, it moves so quickly that textbooks are not really the best option, I don't think.
Yeah, can I do a 10-second defense of writing a book?
Yeah.
So I actually do agree, and this is why I think you you're seeing more and more this hybrid model where the book is open online and is developed online, because that's actually much more, I think, useful for a lot of people to be able to access, even if it's not fully ready. It's better that there is something than there is nothing. And that's why, and I think actually this, as much as I may have some views on the publishing world, I think it's something to recognize also that some publishers are accepting and are letting us develop books that will be published to the traditional route, but that also have a fully open license version online. But also, I'll say, if I need to convince anyone in my job that this is part of my job, there needs to be somewhere you can cite, and a book is better than a website, at least for my head of department or head of faculty. So I think that's why a lot of academics end up going for that route. And if it is to plug also a couple books for R, I'm aware, so Robin Lovelace and colleagues have one on geocomputation in R, which is pretty much up to date on all of the modern SF type of stack in R. And then Paula Moraga has another one in R for spatial epidemiology, I think, which is, both of them are open. So they follow this hybrid model where the book is published on paper through the publisher, but there's a website that has all of the materials online. The only condition, at least that we've had, is that you don't provide a single download for the PDF.
Cool, thank you. So we've got an interesting, we're coming up towards the end, so we'll try and keep it quick, unfortunately, because this is a really interesting question. So we've mentioned getting data, location data from counters or beacons. Is there an ethical issue with this? Because they don't usually ask for consent. Rachel, you're nodding. Go ahead.
Yeah, so I recently was guest lecturing back at Chester for smart cities and ethics in geospatial data. With the rise of smart cities and people giving consent, it can get a little bit cross-wired, especially when you've got GDPR and things like that now. The issue sometimes with geospatial data that I've often told my students to watch out for is that they might give consent for one piece of data, but they're not necessarily giving consent for you to use that with other telling information. So whilst you're putting their specifically agreed data into a geospatial information system, then you're overlaying perhaps, say, financial or business data that's revealing information about them that they might not have agreed to. So there is a very fine line in being open and honest, and if you're doing a scientific study, exactly what you're going to be doing with that. But then it's different when it comes to businesses that are collecting your data through Google Play apps and things. It's perhaps not always so clear. It might be buried in the terms and conditions that you're actually agreeing to it and don't even know. So with spatial data, I think it's challenging. You've got to trust the people that have it to a degree.
It does.
Yeah.
Go on, Dani, please.
Oh no, go ahead.
It does sound like you're getting data from third parties an awful lot. So being constrained by their terms and conditions, especially if you don't always understand the entire process, sounds very challenging. Sorry, Dani, I didn't mean to cut you off.
Yeah, no, I was going to say that absolutely there's ethical concerns, and that's something that I think we're in this sort of gap in which society and cultural norms haven't caught up with technology, and not caught up in a bad way, but just in a way, in the sense that I think for cultural norms to evolve and society to change, it requires a debate. And I think that is a much slower process than what we can do with technology these days. So I think it's really important that these discussions are had much more often. And it might be that we decide that we don't want to collect any data, or we might decide that we want to collect data, but in different ways. And then the other thing that I would add to this is that because of technology in this space, at least, has moved and has progressed in the last few years, mostly to further the interest of basically big companies. The way that we've been brought into this world of individual data and so on is through those lenses. So I would just sort of get inside people and try to get people to think much more broadly than what we have, because there is a lot of ways of collecting data, and if your goal is not monetizing the data that you collect, there's a lot of really interesting detail and granular data that you can collect respecting privacy. It's just that we haven't done it because the people who have the power to collect it don't have the interest. So, and why, why would they, if you follow the market rationale? But I think now that we're realizing that has pretty serious consequences, or it can have pretty serious consequences, is a debate that we should have. And I think there's a lot of opportunity for coming up with creative ways of collecting data that are useful. Going back to what I was saying, in most cases, you don't care about the individual, you care about the group. And in those cases, you don't have to collect individual IDs. You don't have to collect, you can collect granular data that doesn't tell you much or anything about the individual. And I think there's a lot of room for doing that in different ways than we've done so far.
Yeah, I definitely agree with that. Like one of the challenges you have is if you want to get down to that more granular level of detail, obviously there's a point at which you start to infringe on people's privacy, and people working in kind of in the public sector, in academia, will have access to these secure labs where you can access kind of ONS data or HMRC data down at an individual level, but it's on a closed IP. You can't get it out. You have to do all your analytics in there, and it's really useful that the government allows us to do that, but it kind of comes into conflict with the spirit of open data and getting that insight out to people. And I think the way around that is coming up with clever ways of aggregation. So try and work out where the variation is in the data, and then aggregate to those kind of subgroups to a point, just to the right point that anonymity is preserved, and then you can bring the data out and make it more open. So yeah, just being smart with your statistics, I think, is the way to do it.
Yeah, and I think, sorry, just to chip in very quickly, going back to the discussion we were having before about what is it really that the audience that this is meant for wants or needs, and in most cases you might start with a highly detailed data set, but that doesn't mean that your output needs to be that detailed. So to make another shameless plug of Liverpool, some of the work that there's a center called the Consumer Data Research Center, which basically acts as a sort of as a platform that connects private institutions that hold important granular data and researchers who are interested in accessing those data in ways that are useful for the research, but that don't infringe privacy, etc. So that center in itself, I think, is an innovation that I think we should do more, and I think there will be more in the future. But actually, one of the main lessons that we've learned from 5 years running that center at Liverpool is that the main service we thought that was going to be required for that was going to be popular in the center was accessing the sort of the fine granular data, and that's it, because that's what we thought users would want. And what the center has realized actually is that most people don't really care. What they want is insights from those data sets. So one of the mission, not the mission, but the activity has shifted a little bit from providing a platform that lets you access the individual data to providing a service that takes individual data and aggregates them in, like Jack was saying, in clever ways, so they can be redistributed, in this case in open forms and in fully open data formats. But they still tell you something interesting, but you don't have to release the individual data. And I think there's a lot of really interesting creative options that are opening up that I would, if I had to say, in the next 5-10 years, we'll see a lot more in that space.
Yeah, and for a plug of our own, we're lucky enough to have Rachael, who just finished her PhD on machine learning approaches to preserving information while still trying to protect anonymity at the same time. So it's an ongoing field of research, and you can obviously find Rachael's slides in our Twitter feed. Yeah, so we're running out of time now, so we'll just ask one final question. So we've heard about different applications from all of you at the moment, kind of different projects you're working on. What's the most interesting projects and challenges that you're working on in the next couple of months? I know, Dani, you've already named a bunch you've already got going on.
No, I was laughing because the next couple of months are probably going to be Phil trying to move a brick and mortar university to online because of COVID-19. So that's going to be the most and least interesting and only work and job that I'm going to be having. But
Yeah.
I'll let the other speakers expand, and maybe I can chip in later.
Yeah. Jack?
Okay, yeah, so there's a few things going on. Probably the most interesting one is we're looking at a decarbonisation pathway for the North's transport system, and we're trying to do this in a much more spatial way than national government tends to think about this problem. So we've been working with the Department for Transport to get quite a detailed data set of the vehicles across the region and where they are at like middle super output area level, and in quite a fine sort of grain segmentation of how big the vehicles are, how polluting they are, and we're trying to develop a model for how that fleet could be decarbonised over the next few decades. So combining that with the kind of demographic data that I spoke about earlier, we can start to understand the kind of social inclusivity issues associated with that, and where the costs of decarbonisation may be fairly or unfairly distributed. So we're trying to kind of merge together the decarbonisation challenge and some of the economic challenges that we've got there. So that's going to be a really interesting bit of work. We're working with the Institute for Transport Studies at Leeds on that kind of problem through the Decarbonate network. It's a new academic network that's just been established.
Sounds fantastic. Rachel?
Yeah, so I've very recently changed from academia to industry, and the industry stuff that I'm going to have coming up, I think I'm actually allowed to talk about. So I will talk about some of the stuff that I might have coming up with some of my former colleagues. One of my colleagues, we were looking at an NGO and using remote sensing to look at farming practice and seeing how crop yields are going to change in terms of, along with climate, but also local practice and irrigation. And some of that is double checking and validating somebody else's work because their original methodology wasn't clear. So that's going to be quite interesting to see whether it was done correctly or not. And another one is along the lines of smart cities, so more towards rural access and the smart rural. So what are broadband connections like? Is the smart city and smart places going to extend beyond just the city into rural? And what does that mean for the local population? What is it going to be? Because it's still so new that's a big question mark. So that's potentially stuff that I've got coming up in my spare time beyond working for Jacobs.
Excuse me. No, fantastic. Dani, anything to add?
Well, I'm starting now a big sort of 3-year type of project at the Alan Turing Institute that's going to be looking at how we can use satellite imagery to characterize the built environment or urban form for cities. How can we, can we automate it using satellite imagery? And if we can we roll it back to the 2-3 decades of imagery that we have available to get a full time series of the evolution of cities? But that's starting very slowly. So in the next couple of months, very little is probably going to happen on that. It'll be more the teaching for COVID type of thing.
Yeah, that makes sense. It's a shame, but it sounds fascinating. Okay, well, I think that's all the time we've got for today. Thank you very much for agreeing to join us. It's been really interesting hearing all your stories and perspectives, and even some of your hot takes. And thank you much to all of our viewers who joined us. We're going to be continuing the conversation in the Slack channel in #meetup. Yeah, so thank you very much for joining us, and yeah, hopefully we'll see you again next time.
Thanks very much for having us.
Yeah, thanks.
Thank
Thanks a lot.
you.
Okay.